Hey guys, today we're going to be talking about reflections. So this is another type of transformation, and a reflection, it is like a mirror image of something, also called like a flip of whatever our shape is. So when it comes to a reflection, you are going to be reflecting, we say, over a line of reflection. So for example, let's say this is our line of reflection. That's the line we're reflecting over. And let's say we'll do a triangle. Let's say we have a triangle that we'll make it look like this. And if we're reflecting over this line, the reflection, it's like looking in a mirror, is going to be like this. This would be reflected. Like this would be A, this would be A prime. So you're reflecting over the line. When you're reflecting, notice like the orientation is flipped. A was on the left here, now it's on the right over here. That's the orientation flipping, but the two triangles are still congruent to each other. They're still gonna have like the same area, they have the same shape and size, it's just that the orientation has been flipped around. And like I said, A was on the left here, it's on the right there. That's because you reflected over a vertical line. For something like reflecting over a horizontal line like this, we'll do a similar thing. Do it with B. If you reflect over this, you're going to look kind of like that. And you're going to now, instead of having B on top, when it reflects over, it's on the bottom of the triangle, but still the two triangles are congruent to each other. So this is what a reflection is. And with a reflection, we're going to really focus on two of them. So the two lines of reflection we're going to focus on. One of them is going to be reflecting as the x-axis is our line of reflection. So an x-axis reflection. So it's reflecting over the x-axis, and there's a special rule for that. And the other will be a y-axis reflection. Now with all these transformations, it's really just about learning what the special rule is for that. So with reflections, when we go over the x-axis, we're going to have x stay the same and y is going to become the opposite. What that means is whatever ordered pair you have, x is going to stay the same, so x is going to be x, and y is going to become the opposite, so it's going to become the opposite of y, like that. And for a reflection over the y-axis, we're going to have y is going to stay the same, and x will become the opposite. So whatever your original ordered pair is, x is going to become the opposite, and y will stay the same. So you can think of it like whatever axis you're reflecting over x, that's the coordinate that stays the same. If you're reflecting over y, that's going to be the coordinate that stays the same. You can think of it like that. So we're going to do an example together now. So this example says, given the pre-image, w is -3, -3. So this is w. And what else do we have? X is 0, -4. So this is x. This is w. Then we have y is -1, -1, -1, -1. That would be y. And z is -4, -1. So right here is z. So we have x, y, z, and w. So we have a quadrilateral, 4 sides, 4 vertices. And we have to be careful. It says you want to reflect over the y-axis. So if we don't remember, this is y, this is x. So we're reflecting over the y-axis. So when you're reflecting over the y-axis, there's two ways to think about it. One way is to just use the rule that we just wrote down. So like w is -3, -3. But we said the rule, when we're reflecting over the y-axis, x becomes the opposite, y stays the same. So that means w prime would be, actually I'll color code, w prime would be x becomes the opposite, so the opposite of -3 is +3, y stays the same. So that means w prime would be 1, 2, 3, down 1, 2, 3, there's W prime. And notice, in comparison to W, it's going to be reflected over the y-axis. Our next one, we have, let's say x. X is 0, negative 4. And again, we're going to have the same rule. The opposite of 0, well, that's going to end up being still 0. So x prime is going to be 0, comma, negative 4. So x and x prime, they're actually the same point. And if you're reflecting over this line and you fall on it, you're not really going to reflect at all because you're just going to continuously be on the line. Our next point was y is negative 1, negative 1. So when you reflect, x is going to become the opposite. We're reflecting over the y-axis, so it becomes 1, and y stays the same. So you go 1, negative 1. There's your y prime. And our last point that we are reflecting here is our z. And z was negative 4, negative 1. When you reflect that, x becomes the opposite. So your negative 4 becomes positive 4, and your negative 1 stays the same. So 1, 2, 3, 4, negative 1. There's your z prime. So this is what our shape looks like after we reflect over the y-axis. Notice how it's a mirror image over this line of reflection that's going vertically up and down here. Another way to think about this, if you have the coordinate plane, and something that's true with reflections, whatever your line of reflection is, your pre-image and image, they're both going to be the same distance away from that. So what I mean by that is, like this was our pre-image, this was y, it's 1 unit away from the line of reflection, so over here you're going to be 1 unit away. The W, you started out being 1, 2, 3 units away, so when you reflected, you're going to be 1, 2, 3 units away. That's another way you can do the reflections. The X fell on the line of reflection, so it stays the same, and Z was 1, 2, 3, 4 units away, so you'd be 1, 2, 3, 4 units away over here. You can do that as well. We'll do that for the next one. Alright, so our next one, we have these points. We have A is negative 2, 3, negative 2, 3. This is point A. We have point B is 0, 5. There's B. And point C is 3, 3. 1, 2, 3, 1, 2, 3. Point D is 3, 1. So we have this. And we are reflecting over, and this is key, we're reflecting over the x-axis now. So again, this is the y-axis, this is the x-axis. So we're reflecting over the x-axis. Let's start with A. I'm just going to use that rule that we talked about right at the end there about just using the distance away. If we're reflecting over this line here, that's our line of reflection. So we can say, like point A is 1, 2, 3 units away. So if we just go straight down 1, 2, 3 units, this is where A prime is going to be. And if we were to plug in the coordinates and use the rule, we're going to end up here anyway. Point B is 1, 2, 3, 4, 5 units away from the line of reflection. So it's going to be 1, 2, 3, 4, 5 units down here. Point D is 1 unit away, so it's going to be 1 unit away. There's D prime. And point C is 1, 2, 3, so it's going to be 1, 2, 3. And there's point C, so C prime. Then we can look at the reflection, and just like that, you can see now we have a mirror image over the x-axis. If you wanted to use the coordinates, we'll just do 1, so you can see what it would look like. The rule for an x-axis reflection, x-axis, x stays the same, y becomes the opposite. So A prime would be x stays the same, negative 2, y becomes the opposite, negative 3. So you would go negative 2, negative 3, and there's where A prime is. So it works out either way. If you prefer algebraically, you can do it like that. If you prefer geometrically, where you're kind of counting, see how far away you are, you can do it like that. But you should be familiar with both. Sometimes you might not have the coordinate plane, and sometimes you might be just given the coordinate plane and not be given the coordinates like this. So I would be familiar with both of them. All right, here's our next problem. We are given this triangle. This is C. This is point B. 1, 2, 3. And then point A is 1, 2, 3, 4, 5, 2. We have this triangle here. We have this triangle down here. And we need to figure out what transformation took place. So, judging by the notation that we have, we know we're starting at the blue triangle, we're ending at the green. We know that by the prime symbols. So you can see here we're clearly reflecting, we're a mirror image, and we're reflecting over this line right here, which is the x-axis. So we would say this is a reflection over the x-axis. That's the transformation that took place. In the future, we'll talk about maybe you reflected and then you maybe translated. You can do more than one, but right now we're just going to have one transformation take place. All right, now we have a couple more to try, and these are going to be without the coordinate plane, so it's good to know the rules, and we'll leave the rules right here for us. So our next one we need to figure out what transformation took place. We have x is negative 3, 5. It goes through a transformation and it ends up as x prime is 3, 5. So if you compare the two, we'll notice the y's stay the same, but the x's just become the opposite sign. So we can look to our rules here. Which one has y stay the same and x becomes the opposite? That would be right here. So this is a y-axis reflection. If we look at the next one, we have m is 3, 3. It goes through some transformation, and m prime is 3, negative 3. So when you're comparing the two, notice the x's stay the same, the y's become the opposite. So if that's the case, x stays the same, y is the opposite, that's an x-axis reflection. Now you have the possibility that maybe you're not even reflecting at all, maybe you have like a translation. So comparing both the x and the y's is going to be really important when you're trying to combine more than one transformation. So you can go ahead and try these next two on your own, see if you get them. You can check with what I say in a minute here. I'm just going to write them down. And then you can go on and practice some on your own online. So here's our next two. So our first one, we're dealing with r, that goes to r prime. So r is negative 1, negative 4, and then r prime is negative 1, 4. So comparing, your x's stay exactly the same, but your y becomes the opposite sign. That indicates you have a reflection. You just need to figure out which one. Well, x stays the same, y becomes the opposite. That's an x-axis reflection. So that's what this one is. And down here, compare. Your x's, they just become the opposite signs, but your y stays identical. So that indicates you have a reflection. And since the x is changing signs, it's going to be the y-axis reflection. That's all you're looking for with the transformations. What's changing in the coordinates. I'm going to throw in like an extra example in right at the bottom here. Let's say we had something like this. Notice how with this one, oh, I don't think we can see it. I'm going to erase and move up. We have, let's say we had a transformation like this. Notice when you're comparing your x change and your y changes, that's going to kind of be an indication that it's not a reflection, or there's more than just a reflection that took place. So like you're going to be looking for different patterns, and if you look, x goes down by 1, y goes down by 1, so you would say this was a translation. X went down by 1, y went down by 1. So it's all about looking for how did things change, and sometimes you're given more than one point, and you're looking for the same pattern in everything. It's all about observation, kind of getting familiar with what transformations do what to the coordinates. Alright, so you can go ahead and try some reflections on your own now. Have a nice day, guys.